Hey everybody, it's Mr. N, and we are going to talk about angles of a triangle. So let's get started with this, and we can name a triangle two ways. We can name it by its sides, and we can name it by its angles. So a triangle by its sides, and this should say triangle by angles. Okay, so if we've got no sides congruent, we're going to say it's scalene. If we've got at least, notice it says at least, two sides congruent, then it's isosceles. And then all sides congruent, it's equilateral. Okay, so is an equilateral triangle isosceles? Well, there you go, at least two, so it would fall into that category as well. Okay, so by the angles, we can say acute, three acute angles. Obtuse, one obtuse angle, right, one right angle, and equiangular, all the angles are equal. So we got sides, we got angles. So does that mean you can have a combination of both? Yes, you can have a scalene acute triangle. You can have a scalene obtuse triangle. You can have a scalene right triangle. And you can have a scalene equiangular. No, that you can't have that. Notice this one you can't have it because scalene means none of the sides are congruent. But equiangular means all the angles are congruent, and if all the angles are congruent, that means all the sides will be congruent as well. So the last one here, scalene, equiangular, can't happen, but scalene, acute, obtuse, and right can. All right, then can you have an isosceles acute? Yes. Can you have an isosceles obtuse? Yes. Can you have an isosceles right triangle? Yes. Can you have an isosceles equiangular? Well, that one's a tricky one, but yes, you can have isosceles equiangular, and that's a tricky one because of this definition, at least two. Equiangular would trump it because all three would be. So yeah, you could. All right, so now equilateral, acute, yes. Equilateral, obtuse, no. Equilateral right, no. Equilateral, equiangular, yes, those would work as well. Okay, so moving on now. Let's take a look at what we got here. Okay, we've got this triangle sum theorem. And in this triangle sum theorem, it says the sum of the angles of the interior angles of a triangle is 180. But you knew this already. You already knew when you add up these angles. And just let's clarify what is interior angles. These are interior angles. Exterior would be like this. For exterior, the trick is just pick a direction. Okay, so if I start at C and I draw my line this way, this right here would be the exterior angle. Then if I go this way, that would be it. And then the other way, this would be it. So you just got to go in one direction. Pick a direction. If I go A, B, C, extend the lines out, then these would be the exteriors. Okay? So let's get back to this triangle sum theorem. And it says that the sum of the angles of an interior triangle is 180. Well, how do we prove this? Well, a little bit tricky here. What I'm going to do is I'm going to draw a line like this, okay? And I'm going to make this one parallel. I can make a little arrowhead here to this line that's down right there. And if I make them parallel, look what I just did. Because I could draw any line I want. I just picked this specific line so that these two angles would be congruent because these are alternate interior. So then if these two angles are congruent, remember, if I call this angle 1, angle 2, and angle 3, when I add these up, I'm going to get 180. Well, if this is angle 1 in here, well, that would be angle 1 in there. And just the other way around, these would be alternate interior. This would be angle 3 in here. So really what I've just done is ABC, like this. I've called these angle 1, angle 2, and the angle 3, and that's how I get the 180. So that's kind of the gist of this proof. All right, let's move on. We've got a corollary here, and a corollary is just a statement that results because of a theorem, and it can be proven. So it's just another theorem, and it's just a statement, because I said this theorem, I can say this next thing. It just follows suit that you could say something else. All right, so moving on to this next page, let's take a look at this first corollary that we have. It says, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So let me draw out this situation for you, and we'll just do it real quick with a couple triangles here. So if I have this triangle right there, and I call this A, and then we'll call this one B, and we'll call this one C. And I've got triangle ABC, and over here I've got another triangle, and we'll just call this one D and E and F right there. And if I say, okay, angle A is congruent to angle D, and angle B right here is congruent to angle E, well then, because both of these add up to 180, angle C must be congruent to angle F. And that's all that's saying. So then we've got this corollary now to the triangle sum theorem, and it says the acute angles of a right triangle are complementary. Well, obviously, if this is a right triangle, then that's a 90-degree angle, and then that means A and B must add up to be 90 as well. And then we can use all these concepts right here to help develop why a quadrilateral is 360. And you can keep going on and on and on. Why 5 sides add up to be a certain number, 6 sides, and there's a pattern to it as well. So now let's talk about this. And this is the parallel postulate, which is really Euclid's fifth postulate. We've talked about it before, and it only holds true in Euclidean geometry. And this is the one where through a point P not on a line, there's exactly one line parallel. So in other words, if I have a point here that's not on this line, I can only draw one other line that's parallel to this one down here. That doesn't look so good. Let's try it again. That's parallel to this one down here, and like that. Well, this was only works in Euclidean geometry, because we've said if you have a curved surface, the parallel lines don't intersect, so they're not parallel. Now, Euclid wrote his elements, check this out, in 300 BC. Okay? It took from 300 BC all the way until 1823, where Janusz Bolia and Lobachevsky independently, on their own, 2 different spots, they realized that non-Euclidean geometries could be created and could exist where the parallel postulate did not hold. Gauss also discovered this, and we call these things non-Euclidean geometries. And basically, it just means geometry on some sort of curved surface. Euclidean geometry is pretty much on a flat plane, but it works. It works in our situation. The Earth, it's a big distance before we have to take the Earth's curvature into account. So often for our basic calculations, we don't need to, so we'll just use Euclidean geometry. And now we've got this last one. This is another important one for this lesson. It's the exterior angle theorem. And it says the measure of the exterior angle of a triangle is equal to the sum of the 2 non-adjacent interior angles. Okay, so let me explain that to you. This angle right here, angle 1, if I take this, it will equal the measure of angle A plus the measure of angle B. So when I add up A and B, I'll get what this angle is. Now, think of why this is true. Okay, right here, these two, this one, and angle 1. So let's call this angle, say, 2. So the measure of angle 2 plus the measure of angle 1 has to be, we know this because this is a linear pair, 180. Since that's 180, and this is angle 2 in here, if it doesn't look so good in my drawing, if that's 180, we know that this, all 3 inside here, A plus B plus C, has to be 180, right? So on the other side, I could say the measure of angle A plus the measure of angle B, okay, is equal to, plus the measure of angle 2. I forgot to put that in there. That's what this 180 is. I could substitute this 180 with these 3. But look, angle 1 here and angle 2, so these 2 reduce out, so I just end up with the measure of angle 1 equaling the measure of angle A plus that measure of angle B. So that's how it reduces out. All right, let's take a look at a couple examples. We were going to do these in class like we always do, but let's take a look at some of these examples. Match the letter of the figure to the correct vocabulary word in exercises 1 through 4. A right triangle. Well, that would be D. Okay, so that would be D. And obtuse triangle. Obtuse needs to have an obtuse angle. The only one that looks like it has an obtuse angle is A. Okay, so now let's move on. Let's see what the next page holds. Probably the rest of these. Acute triangle. Let's enlarge this a little bit. We have an acute triangle. Let's go back. And that was, we're going to go back and do these two. The acute would be B and C. And then the equiangular, the only one that was equiangular was the B triangle. You can go back and take a look at that if you need to. Classify each angle by its angle measure as acute, equiangular, right, or obtuse. Give 2 classifications for exercise 7. Okay, so this is, we need to say if it's acute, equiangular, right, or obtuse. So for this one, this would be right. For the next one, this is, well, obtuse, because I just need one obtuse angle, and I have it, so it's obtuse. Over here, I have to give 2 classifications for number 7. This is equiangular. We know that right away. So I can spell it, angular. And this one is acute as well. So it wanted us to give 2. Okay, fill in the blanks. An isosceles triangle has at least 2 congruent sides. A what triangle has 3 congruent sides? Equilateral. My pen's kind of having a hard time today. Okay, a what triangle has no congruent sides? That would be a scalene. And classify each by the lengths. Equilateral, isosceles, scalene. Give 2 classifications on number 13. So, oops, yeah, let's move this up a little bit. So let's look at this. This is going to be 2, so this is, we know this one will be isosceles. Okay, then over here, this is all 3 are different. This is scalene. And then on this one, equilateral. And these are all the same. We can also say it's isosceles, right? Because isosceles has to have at least 2. Find the side lengths. A to B. Well, A to B is going to be 15. Okay, A to C. A to C is the same as A to B because of my congruent symbols, so that's 15 as well. Okay, and then B to C right here. Now this one, we just know it as x plus 6. But remember, I said I knew that this was 15 because this is 15. So x is 15, so this is going to be 15 plus 6. So this is really 21. So I knew that one. Okay, we're going to stop right there because the rest of these are pretty much the same. You're just going to fill in some words. But I do want to go down and do these last 2 right here. So over here, find the measure of each angle. So remember, the angles of a triangle add up to be 180. So I could subtract this 30. So that gives me right here. This gives me 150, sorry. And then subtract another 35. And this will be 115. Right in there. And on this last one over here, let's take a look. Well, this is 90. That means these 2 have to add up to be 90. So that means angle F, the measure of angle F is going to be equal to 70 degrees. All right. Hopefully this wasn't too bad. Thanks for watching this. Hit that like and subscribe button, and I'll see you guys in the next video.